Hello, welcome everybody. Today's webinar is called Modeling Oil Spills with OilFlow2D. This is the official release of the OilFlow2D model. My name is Reynaldo Garcia and I will be presenting this webinar today. I just wanted to mention that today's webinar is being recorded, and also you may post any questions during the webinar using the GoToWebinar control panel that you should see on your screens. There is a question frame where you can enter your questions, and we'll be trying to answer all the questions during the webinar. Also at the end, we can have a general question session if we have some time. So let's get started. The oil spills on land is one of the very important issues in environmental handling of oil spills. It accounts for a very high percentage of all the oil spills occurring in either water on inland waters. And it's been recorded between 1980 and 2003, more than 52,000 oil spills only in the US. And this is only in inland waters or in overland. It does not account any spills on docks or water in the ocean. From those, a high percentage corresponds to pipelines or pipeline leaks or pipeline breakage. And this is very important because I will be showing today some applications of the model to this type of oil spills. So the volume that is released to the environment is impressive. So it's been accounted for in this same period from 1980 to 2003, more than 6.7 million barrels only on land and only in the United States. So if you think of many other parts of the world where oil is being handled and transported and produced, the volume of oil that is released on land can surpass many more times these numbers. And this obviously requires environmental assessments. And the environmental assessments of oil spills need to take into account not only the consequences of the event, but also the probability, how often they occur, and the potential impacts, the costs and damages that these events can generate in the environment. And one of the main questions that this assessment needs to answer is where the oil is going to go. Where is the oil going after a pipe leak or a tank break? And this is one of the very important questions that a model can try to answer. The other question that is also very important is how fast is the oil going to get to the different locations. So if you have a pipe leak, it is important to know how long is the oil going to get to arrive to a river, for example. So this is another question where a 2D model or model can help in answering. Now, the oil spills on land modeling is a challenging task. On one side, you have very complex terrain to deal with. The model needs to account for the irregularities of the terrain and also for the complexity of the fluid, which is a viscous flow. So you have a viscous fluid that is much more viscous usually than water, and the spills usually occur in sudden events. So you have a pipe leak, and that occurs very rapidly. So you have a sudden outburst of the oil out of the pipe that gets into the complex terrain, and the model needs to handle that complexity. Also, the risk assessments usually require multiple scenarios analysis. So you need to run the model thousands of times, and that imposes another requirement on the model, that is the speed. So the model not only needs to provide accurate solutions to the questions of where the oil is going to go, but also it needs to provide the answers in a very short time, because otherwise the high number of scenarios and runs that are required will not be practical. Now, the OilFlow2D, which is released today, is very similar in sense, or share many common features to the RiverFlow2D Plus model that many of you may know. It uses the same flexible mesh, so it uses triangular elements to represent the complex terrain and also the complex geometry that you may need to account for. And it also deals with viscous flow. So it can take as data the oil viscosity and density and use that to solve the equations of viscous flow. The model is implemented in a GIS, a graphical information system GUI, that simplifies significantly the effort of putting together a model and a simulation of an oil spill on land. All this effort is a result of a collaboration between Hydronia and the University of Zaragoza. We have an ongoing collaboration that has resulted in a number of very important developments, and this is one of them. Now, what you see here on the left is an animation of an oil flow around irregular obstacles. It can be buildings, for example. So you see these are traces of the fluid going around the obstacle. You see the eddies downstream of the obstacles, and this gives you an idea of the level of detail that you can get from a model like the OilFlow2D. Now, the OilFlow2D, as I said, was developed based on a flexible mesh. And the flexible mesh just means that you can have triangles, but the triangles can be of different size, and the model calculates the velocity and depth of the oil at each triangle. And the user has tools to refine the mesh in many different ways, and that allows you to have a much more accurate representation of your results. Now, the model uses a high-performance finite volume method that provides very low, virtually zero mass or volume conservation error. And this is very important for oil spill modeling as well. The model can handle wetting and drying in complex terrain, so you can have a spill occurring over a totally dry terrain. It can handle also sudden flows. And as I said, the main numerical discretization is the triangle, and the model calculates the velocity and depth of each triangle. The model runs very fast. It's being parallelized using OpenMP in multiple core computers can run much faster than in single core computers. And we have developed already a GPU version for the water model, which is the RiverFlow2D model. And in a future version, we'll be releasing a GPU version also for the OilFlow2D. That would allow you to run the same simulation with the same results, but much, much faster. And when we say much faster, we are talking about 100 times faster, in that order of magnitude. Now, the OilFlow2D uses the generalized viscous flow equations with free surface, and the model takes into account, as I said, the viscosity and density of the oil, and that is translated into a stress. And this shear stress is the one that represents the viscosity of the oil, or takes into account the viscosity of the oil. There are many papers that have been published on the numerical methods and the equations that are used there. These are all referenced in the reference manual that we provide with the model. And I'm going to talk briefly later about the oil spill on land, and that's oil spill on, the oil spill on water. Oil spill on water uses a different method that is based on particle tracking. I'll briefly touching on that. Now, the model offers a mesh generation program that comes with each license. You can pick either the Aquaveo SMS or Argus One. I will be showing today the Aquaveo SMS. Aquaveo SMS is a very powerful user interface that can handle not only very complex terrain, but also can visualize or help you post-process the results to generate animations and many other plots. The model can automatically generate flexible triangular mesh that can be very efficient in handling complex obstacles like the ones you see here. And it offers also a variety of interpolation methods to interpolate the rain data to the mesh. It offers a number of import data formats, ASCII, XYZ, grid files, DEM data, shapefiles, Autodesk, DXF, and rasters as well. The output format, it comes in a number of plots, but also tabular formats for you can get results at cross sections, profiles, observation points, velocity field vectors like the ones you see here, combinations of these plots as well, bed shear, and many other plots formats. It's very easy to visualize the model on Google Earth. So when you have your results, if you want to look at a particular spill on how it looks and how it can be animated in Google Earth, it's very, very simple to do it, especially in SMS, as SMS has a tool to generate animations that provide direct link with Google Earth. Also, the SMS GUI offers a number of tools to generate the mesh, import aerial image as the one you see here. And I want to show you a few steps that you normally follow to set up a model. And in particular, what you're going to see here is a simulation of a pipeline. And the pipeline runs more or less along this mountain here. There is a river running from upstream to downstream in this direction. Usually this river is dry, so I'm not taking into account the water in the river. So I will be showing only a simulation where you have multiple leaks of the pipeline along this area here. Now the leaks can be simulated all simultaneously, or it gets simulated one by one. You can have a single pipe with maybe 1,000 locations where you want to make analysis of leaks, and they can be performed either simultaneously to see the joint impact that have, or you can go one by one, and you can set up a single setup of the model that will handle all those simulation without or with minimal user intervention. So normally when you use the SMS GUI, you open a aerial image that will help to enter some other data here. You import the terrain elevations, and this is an ASCII data file. The terrain elevations are colored here with red showing the highest elevations and blue the lowest elevations. And then you enter an external polygon that indicates the extent of the mesh that you want to generate here. And this is the mesh. You have control over the mesh, as you can see here. This area has smaller elements than this area here because all the spills will be occurring from this side. Now these are the locations of the source. The pipeline follows this line here, and these red dots indicate the spill locations. As I said, you can model the spills one by one. In the simulation that I'm going to show you, all the spills occur simultaneously, but this can be very easily changed. And for each spill, you can enter the OilFlow hydrograph, and that OilFlow hydrograph can vary obviously from point to point. Now, you need to enter some other data, obviously, to represent the oil characteristics, oil viscosity, and oil density. You can enter in either English units or metric units. Turn on the oil spill on land module, and then the model runs, and you can generate this type of animation. Let me show you the animation again. This red dots indicate the inflow locations from the pipeline. So this is about half an hour, so it's very fast. You see here the flows from each of the locations. There are some other, maybe this was turned off, but you see how the spill gets into the river. Now the river was initially dry, and in a future development, this volume that gets into the river, this oil volume, will be able to be the inflow for the oil spill on water. So the oil spill on land, the OilFlow2D on land, will have an interface so that you can run first the oil flow on land, and then the oil flow on water will take that volume that gets into the river and spread the oil on the water along the river. Now there is a very large variety of plots that you can generate using SMS, OilFlow2D with SMS. This is another type of flow that plots that may be interesting. In this case, you see the traces again from the inflow locations, and that gives you a different perspective of the flow distribution. You can also have three-dimensional plots, and the three-dimensional plots are very useful to have the whole perspective of the flow spills. Let me show you here. So this is a view, this is the terrain and the mesh, and you see again here the inflow locations from the pipeline. And then you see this is a very steep area. It's very, very steep, but then you see the flow of the oil coming into the river from each of these locations. Now, the model can be used for any number of oil spill on land, including also tank spills. And this particular application, I want to show you a tank spill. So this is a tank. I'm not showing the tank walls here, just to show you only the oil surface. So the surface is about 10 meter high. So you have a 10-meter tank that suddenly breaks. The tank is surrounded by an embankment that supposedly is able to contain the flow, but I open a little breach here on the embankment so you can see how the flow is going into this other area here. So let me show you the animation. Oops, sorry about that. So the tank is empty now, and the flow goes through here, and it's starting to fill this area here. So this runs. This is an animation of the run what's already done, but is normally very fast. It just takes a few seconds to make this type of simulations. This is another type of plot that you can generate. This is with velocity vectors. So this is the area where the time break occurred. And this is the another view of the traces, and this is interesting because it shows the recirculation of the oil that can be important in some applications. So you see the eddies that occur here in between the embankment and the tank. So with a model like OilFlow2D, you can get a lot of detail that is normally not available with a different type of model. The flexible mesh allow you to refine and adapt very well to these curved surfaces. If you had a model that uses square elements, for example, you cannot resolve areas like this very easily. Now let me talk a little bit about oil spills on water, because although OilFlow2D is already available for oil on land, in next winter we'll be releasing the oil spill on water. And the oil spill on water is actually a successor of a model that we had several years ago. It was called OilTrack. It was a commercial model from 96 to 2001. This one will be a totally revamped version of this, but it will simulate oil spill trajectory and oil behavior on surface water. And when we say trajectory and behavior, we want to say trajectory where the oil is moving over the water, and oil behavior because it takes into account the changing properties of the oil. as it moves on the water. So the velocity field is determined using the hydrodynamic model for the water, and the oil is represented as a large number of particles, and these particles move in the 3D space. So even though the hydrodynamic model is two-dimensional, it can take into account the vertical distribution of the velocity and move the oil in the 3D space. Each particle or each patch has properties like mass, viscosity, density, etc., that change in time and space. So based on the evaporation or the emulsification and the changes that embed on the oil, the viscosity and density of the oil change in time. So there are many physicochemical processes that are accounted for: evaporation, emulsification, dispersion, dissolution, sinking, interaction with the shore, which is important in rivers to account for how much of the oil is being entrapped on the shores. And as I said, the model determines the viscosity and density changes in time based on the effects that each of these physicochemical processes affect on the oil. The oil spill and water model will have a database of oils that will contain a lot of oils that are common worldwide with physical properties, and these properties are used for the determination of evaporation, emulsification, and other processes that are used in the behavior model. And as the model is expected to be released in the first quarter of 2015, and as I said, there will be a link with the oil spill on land so that you can interface the oil spill on land and continue the simulation with the oil spill on water. Briefly, I want to mention the pollutant transport model of the RiverFlow2D model. This is not strictly related to oil, but it can be related to some chemicals that are close to oil. And the oil, for example, some of the oil components can be modeled with the pollutant transport model. This model can be used to as a simple advection dispersion reaction model, including decay of the pollutant. It can handle multiple pollutants simultaneously, so you can solve any number of pollutants at the same time, and the model will determine the concentration distribution of each of the pollutants simultaneously. And it offers also extensive visualization and output options using SMS. As I said, the model uses the advection dispersion reaction equation. It also uses finite volume method in the same triangular mesh and uses the same finite volume method using the hydrodynamic model. And we have very interesting applications of this model, not only for oil spills, but also for other substances. In this case, it's total nitrogen, but the type of applications that you can use this model for are particular in rivers. You can determine the distribution of concentration of this dissolved substance as it moves downstream in the river. Well, a little bit about RiverFlow2D and OilFlow2D licensing. They both license in the same way. We have single user network versions. We don't offer upgrades. We just have a subscription-based upgrading. So if you keep subscription, which is cost about 15% of the license cost per year, you get with that you get all the new versions that are released during the year at no cost, and also free technical support during the year. So technical support and any update, any fix, and any even new major releases are included in this subscription. We offer also academic licenses that are about 50% discounted from the respect to the standard price. And we have also special pricing for government agencies and not-profit organizations. There is a special offer also for the OilFlow2D that is being released at 15% discount, and this offer is valid until November. So the price will be a little higher after that. So now if you have any questions, we have tried to answer some questions through the chat window or the question frame. But if you have other questions, I will be happy to answer them for all of you now.